Hey everybody, this is Larry. This is me going over Q3 of the biweekly contest 139. Find the maximum sequence of value of array. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. So this one I have a lot to complain about before we start. Feel free to fast forward a little bit. But this is going to be a little bit of a long one because there's actually a cool solution that I'll go over in a little bit. But okay, so actually I didn't solve this one during the contest, but honestly, I blame it all on Leetcode. I think this is the problem itself is fine. I think the constraints are very poorly constrained set up. Basically, the ideal solution that they want you to do is going to be n times k times d, where d is the number of digits or the range of the number of digits, which is 2 to the 7. And if you kind of multiply that math out, it is going to be 400 times 200 times 128, which is 10 million, which honestly is a little bit slow on Python side. Apparently it works if you implement it, and there are some like self pruning kind of things, but it is not within reasonable expectation. I don't know. In my opinion, it should not be within reasonable expectations that this would be fast enough. I would also want to point out that because this is like I would also point out that if they had just made this 150, because half of k is 50, this would also be fast enough and it would not change the problem at all. So I think this is a very sloppy constraint setting on the Leetcode side as a result. And I don't know. And I just feel a little bit sad because this was a way, because I think I probably could have gotten this one with about 10 minutes or in 10 minutes or maybe a little bit longer, maybe 15, because I've been programming a little bit slowly lately. But I think it does not fundamentally change the problem, but they made the constraint high enough that I think the people who do submit it either YOLO or they're just very lucky, or they pray, or maybe they just ran out of ideas. Turns out there is a cleaner solution, which I'll go over after this, but that solution is not the intended solution, because if that's the intended solution, this would have been a much harder problem, and n could also be like, I don't know, 10,000 or something. It'll be fine too. So this is like a weird in between where people might worry about timeout. I think my lesson here for myself as a retrospective is that I really as a retrospective to Larry, and I've made this mistake before where I really should have just YOLO and submitted, even if I knew it was going to be too slow, but or if I thought it would be too slow, because sometimes it's not too slow. And the reason why this passes is because there are not that many max input cases, which again is a little bit of a mind reading part, because we have to mind read the problem reader or the problem writer to figure out how many inputs there are, right? So that means that, for example, for this max case 400 times 200, one input takes me about and we'll go over the code, takes me about 0.6 seconds. So if there are 10 inputs, it takes 6 seconds, right? But it turns out there are not that many inputs in the inputs, but how am I supposed to know this? So that's what I mean by mind reading. There's a lot of guessing as mind reading. I think the problem is fine. The constraints are poorly set up, or they just did not anticipate that, that's how people would think about it. Anyway, I'm a little bit, as you can maybe guess, I'm a little bit tilted because I should have solved this one in like 10 to 15 minutes, maybe even shorter. I definitely had the idea immediately, but I thought it would be too slow. Okay, so anyway, let's step back for a second, because that was the Larry retro of what I think about this problem. This is kind of a dubious problem as a result, but as by itself, if you ignore that, it's not that bad. So here, the idea is just kind of brute force in a way, right? So what we want is what we want for this problem is, there are a couple of ways to think about this problem. The first thing to note is that this is subsequence, right? So subsequence means that you can pick any number or no number. So and there is this OR function, right? So the first thing that I would say is, what are the number of possibilities, right? So in the dynamic programming problem solution for just say, let's say 1/2 of it. Let's say given a prefix of this array, then how do we solve it? Well, then we just kind of brute force, right? And how we brute force is just that there are other ways to kind of think about how to generate this, but let's say you have and I'm writing this in a little bit of a pseudocode, but it's more Python code, is that you are going to write this, if you write it with this recursively, you have an index, you have k, and you have the current bit mask, right, that we care about. And then maybe the idea is that you do a tick, no tick thing, and no tick would just look like this, you don't change anything, and a tick would be, k-1 mask you all the nums of the index, something like this, right? So this is the tick, no tick thing. So what does this mean for us? This means that for each of the n index, right? So index can go from 0 to n, and k could obviously only go from 0 to k, or maybe that's for each of the k, right? And what does k mean here, right? That means that we're the number of numbers used, right? So it goes from 0 to k because that's what we care about. And then mask is just the bit mask that we get from OR, right? So okay, so that means that for each of the n index, for each of the nk, for each of the k's, the used case, all we have to do is now keeping in mind that nums sub I only goes up to 2 to the 7, so that means that we can actually take advantage of it, right? 2 to the 7 is equal to 128, right? So then for each of the bit mask, we can generate to see if it's possible. So another way to think about this is that is each of the masks possible? And well, a mask is possible if using k items is possible if a mask is possible using k items and index, and basically this, right, is possible index plus 1 or something, right? Index minus 1, sorry. A mask is possible if, so this thing, really, right? Minus 1 items and we all this index, right? So that's basically the idea here with the tick no tick, right? And this is another way of writing the tick no tick. So then now what we want to do is we aggregate, right? So then now what we want is that for each prefix meaning the prefix of the array, give us what are possible. Give us which bit mask is possible to construct with exactly k items, right? So that's basically what we want to do. And when we're able to do this, then we can also do for each suffix. And the suffix is just the other side, right? So there's no for each suffix. So then now give us which bit mask is possible to construct with exactly k items on the suffix, right? And then once we do that, then now we can just do a brute force thing, right? Of every bit mask. So what would that look like? Well, there are n prefixes with their corresponding suffix, right? And and there are 120 bit masks. So this would take n times 128 times 128 times, right? So that's basically the idea with dynamic programming, is that we're trying to basically use dynamic programming to construct this query yeah. So what we want out of DP is that for each prefix, oh yeah, I guess this thing, right? And we can construct that from a bottom-up. What I did was a bottom-up version of this, and which we'll go over in a sec, right? So okay, so this is my code. It's actually pretty short, and you could watch me upsolve this after, during the video, and I kind of, because as soon as basically what happened is that as soon as the contest ended, I took a peek at the first solution, and I saw the complexity, and I was like, oh, I could do this. And of course, I'm a little bit annoyed because I was like, I could have done this during the contest, but I thought this would be too slow for the reasons that we already talked about. But in any case, this is how I do it, right? So I do it with a set. Apparently, you don't even need a set. You can actually use an array of 128 characters. But yeah, I did it with a set of bit masks, right? So then now, right sub ij is, you go to this, and I actually did the suffix first for whatever reason. The suffix starting from I, using j elements, contains a set of possible bit masks. So okay, so here we start with with 0 element you can only construct a 0. So that's basically what I have, right? So and I set that up here. I make a copy of the previous one as we said, right? Remember that for this one we're doing the suffix, so we're going from right to left. So here we just make a copy of the set. Make a copy of the set with the same j. This is the no tick, right? So basically this is saying that, okay, well, we don't take it from the previous thing, then the j, the used elements remain the same, so we want to keep it the same, right? So we just make a copy of it. Otherwise, we want to use num sub right, or num sub I think. We want to use num sub I, so then we basically look at, okay, if we use num sub I, then we look at every possible previous possibilities, which is in this thing, right? The previous index. This is j-1 because we used one fewer, so that we kind of constrain the number of usage on the k dimension on this side, and we just add this as a possibility, and we just do a regular OR. That's pretty much it. This is the suffix idea, right? And I do the same thing on the prefix. I just make sure that the indexing is correct or whatever. So yeah, so I do the same thing on the index, and then at the very end, as I said, we just combine them. Of course, yeah, I just do some indexing magic to make sure that we have enough elements on the left and on the right. But basically, this is saying that, oh yeah, so let me just, to be clear again, right? Yeah, so then now we want exactly k elements. This is how I have the k thing here, and this is how I have the k thing here. We want exactly k elements on the left side and the right side, and we want the prefix of left. Left is I+1 because I have a 0 index, so that we only update I+1. But yeah, so then this is x on the left side, y on the right side, all possibilities. So this is saying that, okay, this is kind of like the classic sliding window thing, right? Or sweep line, sorry. The classic sweep line thing, I'm drawing a line, right? I'm taking up the drawing. So basically what this last part is just saying that, okay, and I'll just visualize the entire board real quick, right? So then now we have this array, right? And basically, and we have this sweeping line. And we already construct that what is possible on the left side and on the right side for using k exact items. We get all the bit masks, right? And basically now, as we do this suffix prefix thing, all we do now is just look at all the possible bit masks on the left side, all the possible bit masks on the right side, and then brute force checking it. And that's pretty much it. So what's the complexity for this one? As I kind of hinted in my rant, this is going to be this is O of n loop, this is an O of k loop, and this is an O of bit mask loop, right? Because this is the previous bit mask, and as a result, this is going to be O of n times k times, I call it d as in the domain, which is the number of bit masks, which is 128, right? So that's basically the idea. Time and space is also O times k, n times k times d, right? For the left side, it's the same thing. It's just a prefix. You could do this in a little bit smarter way by doing as you sweep, but I didn't do it this way. And then this one is going to be O of k times k times k. Oh, sorry, no, O of d times d times d, because this is O of n, this is O of d, this is O of d, and that's pretty much it. So that's the idea behind the intended solution, and I suspect that this is the intended solution because, well, it's fast enough. There is a better solution though, right? So it turns out I didn't think of it during the contest, and actually during the contest I was actually trying to get that other solution, but I was stuck on this idea of getting exactly k pieces on the left on the right. So the idea about this, the separating out from the left and the right and then solving it, and then reusing the states in a good way, which is how we kind of construct this. Is basically the idea. So this is the part where you split it from the I to the left, I to the right, and then we solve it this way. And I think, but yeah, let me show you this real quick. So that's basically the idea for this one. Yeah. So this is the code. This is just the right and the left, and you probably could do a little bit of drawing, and abstract this for stuff. I am going to go over a little. So the hard part about this is that for this particular one, right? So I was thinking along the other way. So let me try again. So the hard part about this is that for me, during the contest, I was thinking about how to get exactly k using this sweep line thing, right? But it turns out I didn't need to get exact k. I could have done this another way, and this is the idea behind the other solution. And the idea behind this other solution is that instead of saying, so basically in the previous solution we go, okay, for each prefix and suffix, we want to say, is it possible to construct a bit mask using exactly k elements, right? So that's the thing that we were trying to do for the last problem or the last solution. But another way that you can think about this is, and it took me, so apparently, just as a disclosure, someone showed me this on the forums. Apparently, ChatGPT came up with this, so I didn't come up with this. But as soon as I saw the idea, I went, okay, let me see if I can upsolve it. I didn't record the upsolving part, but I did write my code from scratch. So I don't know if it looks similar or not, to be honest, because I just remembered the idea and I was like, okay. And the idea is this, is that instead of asking this exactly, right, is that we ask two questions. Is it possible to construct a bit mask using at least k elements, right? And also at most k elements, right? Yeah, so that's basically the thing we changed this problem to, is that for each prefix, is it possible to construct a bit mask using at least k elements? And what do I mean by that, right? Meaning that if we take, we have one bit mask, do we have at least k elements or more that is able to construct this bit mask, right? And the at most is, do we, if we want to minimize the number of elements to create this bit mask, can we do it in fewer than k elements, or equal to, I suppose, right? With at most k elements. So here, so we now decompose this problem into this problem, or these two problems, and now apparently, there is a way to solve this. But yeah, but basically now, and you know, I think if you say it in these two problems kind of way, then now you can tell how to solve each of them differently. And yeah, and I actually can solve them together, but the code is gonna based on this idea. Like I said, I didn't record this. Maybe I should have, but you know, it's just me typing it out and trying to work it out. And the working it out, like, it's just based on these two ideas. So okay, so the at most part so let's break it down, right? So now we have these two parts. We go, okay, it's a part at most elements. So what we want to do here is greedy. That's pretty much it, right? So for this part, what do I mean by greedy? For each prefix, just count the number of numbers that can be constructed using this, right? So that's basically it. Yeah. So that's basically the idea, right? Is that yeah, for each prefix, just count the number of numbers that can be constructed using this thing, right? So what I mean by that is, I said prefix, sorry. For each bit mask, oh, sorry, my bad. For each bit mask, just count the number of numbers. So for example, we have, say, our bit mask is equal to 7, right? If our numbers is going to be 1, 5, 7, 3, whatever, right? If these are our numbers, well, the thing is that if we want k is equal to 1, or maybe this is a bad example. Let's say this is let's say this is 6, right? I don't know. Right, so and k is equal to 2. The thing is that maybe k is equal to 3, right? So here, if we look at this is the prefix. Well, can we construct this? The answer is yes. But how many elements does it take? Well, it only, in a minimal kind of way, only takes 2 elements. Or actually, sorry, 1 element. 6 is good enough. But we can keep on adding these numbers because it doesn't change the OR of the result, right? Because if we do an OR of 6 and 2, we can add these numbers in without worrying about it changing the result. So that's how we do greedy. And then now the other part is at least k elements. Then it's going to be dynamic programming, right? And this part, yeah, this part is just very similar to how we did the previous portion, but it is just, you know, it is just calculating it recursively, right? So here, yeah. And here we do need the k. Sorry, we don't need the k. We need the index, but we need to. Yeah, it is very similar to knapsack, right? Basically, the idea is that, yeah. So some state of, so it's going to be the previous prefix, right? So we look at all the elements from the previous prefix, right? And then it's either the previous prefix plus 1 for tick and previous prefix plus 0 for no tick, and using an OR operation, right? So that's basically the idea behind solving it, constructing from here into here into here, right? Into these two components. And now we'll go over the code. So here I just have calculate prefix. Yeah. I have the min, meaning the minimum number that we can construct, and max is the maximum number that we can construct. We have an n by mx matrix, and yeah. this is the base case where you have, if you have, it takes 0 elements to construct zeros, and we actually copy it over. Yeah, we copy it over as part of the implicit thing. But yeah, and the min is that. So here we set up the first element. So for the first element, we set up so that index 0, the first element is going to be 1 because that's the minimum number to get to this bit mask is 1. And here is just that we're saying that, okay, if this number is a sub bit mask of j, then it doesn't change the answer for j, so we can count this as +1. So we go over the entire thing here. There's also one more implicit thing here, is that min of index of min of ij is going to be infinity. So if it is infinity, that means that it is not possible. So that means that min also keeps track for us whether it is possible to reach a bit mask, right? Or it takes less than infinite number of them. So that's basically, this is the base case, or well, it's kind of the base case for one element. This is the base case with 0 element, and then after that it is just this transition, right? So then now for each bit mask we go, okay, well, this is the no tick, right? No tick, because it's just literally copying over, and we just do a min just to make sure. And the reason why you need to do a min is because we don't always process this in the same right order, but that's fine. And then this is tick, right? So tick is that, okay, we have, so the previous is going to be the j, so then now we take it. So we take it from the previous j. Sorry, j is the bit mask, by the way, right? So the previous j or num sub I is going to get updated. So this is more of a push. So it's a little bit awkward placing, but yeah. But then it's going to be this one plus 1, and then this is the new state, right? Because j transitioned to an or, and yeah. And then we keep track of the max. Max, we just copy it over for from all numbers. And if it is a submask, we increment. So that's pretty much it. So then now we input the minimum for the prefix, minimum for the, maximum for the prefix. We calculated once for the prefix, one for the suffix. Remember to reverse the min and the max. And that's pretty much it. So then now, this loop is very similar to the previous code, if you recall from here. It's just that we try all possibilities and check out if this is right? So you can actually, in theory, if you have all these other things, you can plug and play this stuff, kind of. But yeah, but basically this is saying that for each bit mask in, okay, so for each prefix I, we look at the, for each bit mask, we want to see if we can do it within k times, meaning that, if we could do it with fewer than k moves and greater than k moves, and then we also check for L, for the bit mask L, and if it's good for both the prefix and the suffix, we do a J XOR L, and that's pretty much it. So what's the complexity for this one? Well, sorry. This is going to be an O of N loop. This is an this is an O of D loop, where D is the domain, where the domain is just the number of bit masks, in this case 128. So this is going to be N times D, right? As you can kind of see, because we do O of 1 operations. And that's the expensive part. So this is going to be O of N times D, right? Time and space. In this particular part, it is still going to be O of N times K times K, time and space, right? For this one, I think you can, you can actually optimize this part a little bit, but by putting this stuff into because this, you could pre-process this separately. So this is time and space, right? Oh no, sorry, just time, not space. Why I think I just intuitively time. It's just all of one space because these are just loops. But yeah, so this is all of time, but it can be optimized into O of n times k with a try, right? Because basically the idea with the more, so yeah, this is just brute forcing everything. You can actually optimize this to n times k with a try, because note that the suffix part will only keep adding numbers, right? As oh no, the other way. The prefix part will keep adding numbers, so you can put this in a try when new numbers come aboard, meaning that with maybe you could. I'm not gonna write this out, but maybe you could say maybe you have a t is equal to some try, and then here, if this is the case, we have t dot add k. Oh, sorry, add j, where j is the try, and then now for the suffix, while this is good, we can do instead of doing this thing, we can go do a try traverse L to give you the best j, right? So you can do something like this in theory, right? I'm not going to do that here because that's another upsolve, but that and you could, if I had a try template, maybe I could have just pasted in, but this would reduce this to n times k, and yeah, I'll let you upsolve it at home. I'm very tired today, so that's pretty much the idea behind this one. Yeah. Oh, sorry, I said k. This is n times d, not k. Time, but can be optimized to n times d with a try, and yeah. Actually, you know what? Let's live solve this. Let's upsolve this using a try. Okay, right. So yeah, so we can rewrite it this way so that it updates it into a try. And the reason is because then now we just try to see, and this is a very studied problem, or it's that, okay, yeah, let's go over that real quick. Okay, so I'm gonna live solve this part. Yeah. Something like this, right? And we just, I think just existent is fine, right? So I don't think we need to do anything. Right? It's a binary edge, right? So whatever. Right? So then now we have an add function, right, for an x, and then it's just current is equal to self.root, right, for range of 7, right? If x is greater than 0, then yeah, current is equal to current.add, right? Current. Oh, what am I doing? This is that would be very sloppy. Yeah, then this goes to 1, right? Else current is equal to current.0 or something, right? But yeah, these are none, so here we have yeah, maybe the way that I wrote it is kind of yucky. I say nx is equal to 1, right? So then if current dot edges of nx is none, then current dot edges of nx is equal to a node, and then current is equal to current dot edges nx, right? And that's pretty much it. We don't need to do the count or anything. because we already done it. Everything in the node, we can assume it exists. So then now we just do a traverse, right? So then now, remember, traverse, we want to give the maximum answer, right? Not just add. So then now here, if x, right? So that means that current bit is a 1. So we want to see if a 0 exists, right? So yeah, so then now, yeah, 0, 0, else nx is equal to 1, right? So because if it's a 0, then we want 1. And the reason is because this is an XOR, right? Yeah. And we also want to, if they both don't exist, then you've done something wrong. So I think this should be good. Yeah. Okay. Yeah. And then now current is equal to current dot edges of nx, right? Oh no. We have to make sure that it exists first, right? So if current dot edges of nx is not, if it's none, then yeah, then nx is equal to 1 minus nx. Basically, the idea here is that, okay, we greedily take to see, you know, if current bit is 1, we see if 0 is exist. If it's a 0, then we see if a 1 is exist, right? So here, the greedy choice is not available. Else, then the greedy choice is available. So then we want answer, we want to, so then that means that this bit is going to be 0. If you are curious how this stuff works, I think this is a Leetcode problem. So, none type has no attribute edges. So current is none. So I made some mistake. But yeah, but this problem, I think there was a problem that's probably like, I don't know. It's definitely on Leetcode. It's a tough problem that's on Leetcode. So definitely check that out. But yeah, but for now, let me debug this. Which one is this, on the add or on the traverse? Am I adding the right thing? Yep. Oh, I guess it could be just have nothing on the root, because this number is too small, because I was a little bit sloppy. Because if you have at least one node, this should be good, right? So, okay, so that means that, yeah. I'm just lazy, so here. Yeah, okay, there you go. Let's give it a quick submit. Yeah, so now you can see that it can even be optimized even more with a try. I know that I didn't go over this part in that much of a detail. It is part of another Leetcode problem. It's about finding, I forget what it's called, but it's about finding max, like 2 elements that are max, give you the max XOR, and it could be a big thing, and that's basically the idea. So yeah, so now apparently you could do this n times d time with a try, and that's all I have for this one. Yeah, let me give you the code real quick. So this is my try, and you saw that I did this live. So this is the try for one maximum answer for XOR, right? This is the prefix calculation for max min, keeping in mind that min to get to a bit mask, and yeah, and then I remember the reverse, and then here's the brute force checking all the possibilities. That's all I have for this one. Let me know what you think. Thanks for watching, And yeah, you could watch me solve it live in the contest. Next. True, false, true. All right, let's go. Come on, please. Okay. Very easy to make a silly typo. Oh, people got it already. Which one am I looking at? Okay, there are people who gotten both. Well, one of whatever. Don't have to pretend they just fix solve the problem. Read the problem first. Just woke up. Okay, nums positive integer k. XOR. Okay. Basically, you want or of half of them and then XOR the other half. 400 numbers. What does that mean? I mean, it's a hard problem. Take your time. Num sub I is 2 to the 7. So what are we trying to return to any maximum value? Okay. So k. Oh, subsequence. They should define subsequence still. Well, I didn't even see it until I looked at the example. Two to the 7, right? Start the trick. It's 2 to the 7 again. 128 times 200. Or something like that. It's a knapsack. Oh, k is exact, that's right. Okay, it's not variable k, that's right. Okay, maybe that means something. So okay, so that means that we want to. This is such a weird way of putting it. We just want half the numbers. Oh, okay. So k. K is do dp on k. It's 2 to the 7 again. Just 128. Focus on the 128. Wait, yeah. Left, right, combine, right? Yeah, okay. That sounds right. I think Alex is good at this bit. Not, Would you want to do a bit mask or bit mask to make it faster? But okay, fine. Right. Oh, I can't do it. I'm doing this wrong. I forgot you have to do K. I forgot you have to do K. So that focus, Larry. Okay, you did it wrong. Okay, that's fine. Forgot you have to do K. Okay. What's that? 200, 200. I guess that makes it a little bit too slow. Hey, 5 millions on the, it's on the cusp. If this is a bit set problem, this would be very sad. Is it right though? Yeah. Chef. It's not a pure chef either, is it? Is this thing? Is the other one doing any better? Roughly the same. Should be solvable. Okay, let's do it a bit at a time, bit at a time, bit at a time. What would a bit at a time do? Okay, you're trying to think too much. Let's keep it here for now, but okay. Bit at a time, bit at a time. Okay, so you have 7 bits. Okay. So basically you want, can I do it a bit at a time? Because I have to choose the subsequence. Man, I'm slow today. Okay. I mean, this is just TP, right? So left. No, that's way too much, isn't it? No, because it's just okay. No, that's fine. You know this line. So 400 square. It's way too big, really. Because it's subsequent, so everything is possible. So now that's too big. Maybe I could do this and then just see if I can. Because then it's just. No, because you could have zeros and then ones on the other side, right? And you just solve it backwards, maybe? Okay, we want ones on the. No, you can't do it backwards because it's bit by bit, right? I don't know. I mean, I have some ideas, but. Is this one easier? Yeah, maybe slightly, but not that much. My people solved, but okay. Bit by bit, still sounds kind of funky, but. What is that? is 400 times 200 times 128, which is 10 million. Maybe I did the math wrong. This would never work. Oh, maybe it's too slow. It's a bit by bit strategy. I can't sort because you can't. It has to be half, so the ordering matters. Is it case analysis? How do you get case analysis that quickly though? I think it's case analysis, but it's still kind of awkward. Okay, so that means left is left and right is right. Okay, so then now we want to see if this is possible, right? And square, so maybe that's fine. If left is 0, that means that all the numbers have to be 0. If right is 1, we can just choose all the numbers, right? Okay, fine. I didn't even do the harder one yet. Nope. I have to do this loop backwards, actually. Yeah, okay, that makes more sense. If it's 0, then okay, fine. right we can keep everything because right is 1. But then there's all these combinations that we have to do. So now we keep track of the good numbers on the left. Right, we should be able to find at least 1. Is I'm doing fast enough even? Okay. Good on the left side. Maybe I just don't know how to do it. Now focus, bitwise. Left has to be C. Because then you have to branch out. That's the hard part. Well, I mean, that's one hard part. Yeah, I just don't know how to do it. I mean, all my ideas are kind of the same, honestly, on brute force. And the thing is that it is not a sub-array, this is a subsequence. So this is actually pretty big, 400 times 200 times 2 to the 7. It's 10 million. 10 million is too big, Larry. How do we reduce this? I should have looked at the other problem. Alright, let's take a look real quick. That's more solutions. Back to this one that I don't know how to do. I'm getting tilted on 10 minutes. I knew that one, but then I just kind of got sloppy on the tiebreakers. Focus, reset. Okay. We have a left side and a right side. Are they all possible? Yeah, it only takes like 7 things to make it all possible. How am I doing? The 10 minutes kind of hurt though. Oh, this new layout again. Because there should not have gotten wrong answers on this one, but wow, people are very fast. I am not doing well then. But because I'm not even close on this one. The Q4 was so straightforward. I just didn't. Some like partitioning thing. With a 10 minutes penalty from stupidness. I'm not awake. That's my excuse. Not awake for this problem either, huh? Okay, yes. Can I think of it backwards? Bit at a time. Bit at a time. Okay, I see. Maybe. I see. Maybe. I don't know. Bit at a time, right? So for that, okay, so that now. Yeah, I think I played with this idea before. I don't know though. Okay, so then. No, you still have to keep track, Larry. That's why. That's what you were saying. N square. No, and you still have to do. Oh no. No, that's fine. You don't have to keep track of K because you could do greedy. I see, maybe. I don't know if that's true. you can just do greedy. Okay, or you can count in constant time. Can you though? No. Can you do it a bit at a time? No, because I have to filter those things out. Okay, so let's say you have 0. No, you have to keep track of all the. You have to keep track of the previous numbers. So okay, so. Because you have to do all the combinations of all the previous ones as well. So if it was ones, then you have to keep track of all the zeros or the ones. Okay. Zeros and ones. What does 0 mean? 0 means they're all zeros. K zeros on the left. 1 means well, just any one, but you have to keep track of what the previous bit is to narrow it down. You have to branch that out. No, I keep on coming to the same ideas. Alright, let's see if we can reset. Because numbers could be on 0 on the left and 1's on the right and alternate. Because it matters which. Also, I should have skipped this one apparently, but that's not great. The 10-minute penalty. Oh, wow, people got it in 3 minutes. I don't like this new layout, by the way. Or the colors, it's just so confusing to look. We got it in 5 minutes, so it must be not that bad. Well, these people are very smart people. But, what am I missing? mean, I could improve my solution with a try, but it's still too slow. Too slow. Okay. So can we find a... It's a 1 if all these are zeros. And all these are 1s. Maybe I don't do the left. Well, how are they? All these are 1s, but just at least 1, 1. Right? So it's about... So what is it about, Larry? What is it all about? But you can't keep, because that's the thing, isn't it? You have to keep track of all the possibilities. Okay, let's say we have left and we have 1 bit, right? No, because you just have to match them up. It's... I just don't even have an idea at this point. I mean, that's the thing. I have half an hour left. The XO is killing me. Because min is not also min, right? Necessarily, we can't just do a greedy min. Because we might... How is this easier than the other one? How did I dig the K part? It wasn't for K. This was okay. Okay, so without the K part, we just do a left right, we do a rolling sum, and we did that already. And now we want to care about this is techno-tech. It's I mean, it's YOLO time, I think. So maybe we just do it anyway. I mean, yeah, I don't think this is going to be fast enough, but at least we'll try. You don't know, this isn't even close. So I guess technically it should be this first. What am I doing here? Okay, so then now what do we want? If this is a 0, okay, so we want to see if bit mask is, so it is, can I do it in one way? One way or another, do. Maybe not, maybe I have to do it, maybe we have to do a lookup on this. I mean, in theory, this is where you have a try, so maybe this YOLO isn't even a good idea. Maybe I didn't think this through. Maybe this wasn't gonna work anyway. I thought I could maybe count it down. Can I count it down? So let's say if this is a 1, then the rest has to be zeros. Because if there's a 1, then we XOR it, right? This is a 0 and this is a 1, then we do get a 1. And no, because you have to care about the right side, not just this one thing. So you have to keep a... I just don't know how to do it. Maybe this isn't right. I mean, there was the other way of doing it, but well, it's just too many. 128, 128. Yeah, even that would have been a little bit tight. How do I handle the K? Alright, let's think of if K is equal to 1, then we just have one number here. Okay, that's not helpful. 2 to the 7 though. I think we should be able to do something with 2 to the 7. Can we do a bit set that easily either? Because it's not just shift, right? It is yeah, you can do a bit set because it's an OR. Now I have 20 minutes left and I still don't know how to do it. Maybe I should have taken the time off. Oh well. Can I do the opposite? Can I just remove numbers? because the contributed over bit may not be the same bit. How am I doing on time anyway? Not so well, I guess. Put that in 2 minutes though. What am I missing in 2 minutes? I don't know, but TS Reaper is pretty good and he got in 10 minutes. Scan Hex did it in 9 minutes or something, so I don't know. Maybe they have some helpful tools or something. 10 minutes. But 10, I mean, I've been way longer than 10 minutes, so Okay. Okay. Can't sort, you can't do anything. Does that look like? So let's say we want no, it's just the same old filter right now. Is there a pigeonhole thing? 128? No. And accounts matter because, oh no, they're or, so they don't. zeros are just all of them are zeros. One is just having one number as one. So as long as we have one number, as long as we have one number in a bit, it's fine, right? So then now we get to find the possibilities. Because we could always get 0. We're just trying to see if we could get ones. Is that true? Okay, you can always OR more numbers. So then now the question is, can you to get 0, 1, you don't care about the zeros. I don't know how that's faster though. I can prove that it is faster. It still sounds like the same thing. Yeah, I don't know how to do this one, I guess. Spent an hour on it. Q4 I did pretty quickly, even at 10 minutes of penalty because I'm dumb. But I should have sneaked ahead though. Should have at least peeked ahead, matter. I'm just gonna do greedy, why not? I don't know anymore. Maybe YOLO submit a little bit. Yeah, I don't know how to do this, so So I'm just doing random things. This is not right. Or probably not right. But I wanted just to see what happens. Okay. Yeah. It'll probably work with the inputs, but I really don't know how to do this. This cannot. Oh, whoops. Oh. This isn't even right for this. Why isn't it though? This +1 maybe? Yeah, well. I have no idea how to do this, honestly. And there's 5 minutes left. It should be, oh no, this is for 1. That means that I greedy on both ways, but I think those are all the possibilities. Yeah, so I don't know. On a greedy way. I was hoping greedy would work because I have no idea. For what number though? What is the answer? Like, why doesn't greedy work? My answer is 115. Oh, the answer should be 122. It's 8 and 114. And 114 would not be, yeah. It would not make sense for, okay, so that, I thought it would be like a prefix suffix greedy thing. Well, I mean, I didn't really think that hard about it, but why not 8 and 123? I don't even know how that works. Oh, I see, because of this bit. Okay, that makes sense. Yeah, I don't know how to do it. I was just hoping that greedy maybe, I don't know. Because it's the only thing I could implement in 10 minutes. Yeah. I mean, a lot of people got it. I just don't know how to do it. I feel like I'm missing an idea. I am gonna so there's 2 minutes left in the contest. I am gonna try to upsolve it. So we'll see how that goes. I don't know though. I feel like I've worked on this problem for the entire time, pretty much. Like Q4, I don't even remember what the problem is anymore. And I'm certainly not gonna type something out. I mean, the only thing that I can think about is maybe that DP that I was thinking about, but I thought it would be too slow. So maybe there is. I think there is some like pigeonhole things if you ask me, but I don't know. Yeah, I don't know how to do it. Can we wait? Yeah, I didn't get Q3. And I took too long to look at Q4. Good job. If it's legit, good job. The K part threw me off though. I mean, you could rephrase this, but if it's so, there's 1 minute left before. My two guesses are DP or case analysis. The case analysis I struggled with, so maybe I'm missing like one part of the case analysis. Yeah, and we're done with this crappy contest leaderboard UI. Did ChatGPT win? Yep, seems like it. 2 minutes? Come on, man. At least, okay. Just a, no, that's not a try. That's basically what I was, Did I think this would be too slow? That's what I thought I had though. But what are they doing that I was not doing? I mean, I guess this is how I thought I would do it, but I didn't think that was fast enough. Why is that fast enough? I guess so, but let's actually. I really thought it wasn't going to be fast enough, honestly. I mean, I think I wrote down most of it too, right? So okay, let's actually upsolve this real quick. I mean, I got it from ChatGPT anyway, but I thought this wouldn't be fast enough, honestly. Because I wrote most of it, but. Yeah, so I had something like. I thought this was, how, maybe I should have tried it, I don't know. I don't know. I didn't. Okay, so the previous is going to be equal to right sub I plus 1j. So maybe actually we should do plus 1 here, should be fine. No, j, right? And then basically you either tick or no tick, right? So right sub It's like a min of also this should be k plus 1 anyway to get k, but n minus I plus 1 or something. So n is going to be 1. Okay, so then now this is the previous. I thought it would be too slow, honestly, but that makes this problem actually kind of sad, or not hard. They chose to bounce very weirdly, honestly. Like this could have been, I don't know. Not really, unless I'm really bad on the math, which is possible. It's okay. So we do the don't tick all at once, right? So that means that maybe I missed an optimization. How is this only 2 loops? No, there's another loop. Okay, but yeah. How do I make a copy of a thing? Like I want this. Okay, so maybe I just do this then apparently. And then now for tick, right? Whatever. Is this right? I don't know if this is right. I don't think this is right. I think this is right though. And that if j is 0, why would j would be 0? Okay, so we start at 1, right? I guess it's okay to have 0 actually. I don't know. I just have trouble not thinking that this would be fast enough. That's why. I guess I should have just YOLO tried it anyway. But I need to be. I think Alex told me this before that I don't know. Leetcode is just garbage with respect to the complexity timing. Like this is because we did the math, right? It's gonna be 400 by 400 ish. 400 200 by 128 is kind of slow. But they make, like, if they have just made the bounce 200, this would have been so much cleaner, right? Like, what is the advantage of having it 400? I don't know. it's kind of crap. Anyway, we'll test this later. All right, and then now for the left side. Oh. Yeah, whatever. I'll just do it the same way, I guess. I'm not gonna. I was gonna split them up, but. If I is the first one. Yeah, I guess I shouldn't do it that way. Okay, fine. Let's just do it this way. I mean, this isn't even that interesting, but. I'm just kind of getting distracted. Sorry, getting distracted because I'm hating right now. Yeah, whatever. Let's just do it this way. It doesn't really matter anyway. We'll just do oops, why did I have this as 1? That's actually pretty bad. Alright. Yeah, I mean, okay, fine. Right, and then now fine, and right, we have left sub IK. I guess this is K and minus K plus 1. I mean, this is such an easy idea. I just really thought that this would be. Sorry, I'm just like a little bit annoyed about it. Yeah. Yeah. I think this is right. Maybe it's off by 1. Maybe. I don't know. Oops. See daisies. This isn't even right. Copy and paste sloppily. Okay, so this one it doesn't matter, but this one it does because. No, we would n plus 1. How did I vote this? now 0. 0 is going to be 1 element. I don't know. I mean, I think I'm off by 1, honestly, still, but it's fine. Oh, this should be min of k. Well, I'm just annoyed because this is... Oh, no, this should have been... Am I doing this wrong? Probably. I did not. I mean, I like the problem. I don't like the solution is dumb. All right. Okay, what am I doing? Why isn't this right though? Oh, this is left. Am I only putting left? Well, I guess both of them should have something good. Okay. This should have more than... Oh no, 7 sounds right actually. For the right side. So... That sounds right, but this... I guess this is a poor example for the right side. I mean, maybe the bounds are not right, but... Alright, well the left side is definitely way wrong, but that's fine. J minus 1. So this should have something, right? Why is this? I'm just so tilted. Start at 1. K plus 1, I plus 1. Oh no, this should be... No, that's right. No, maybe. Okay. I think my indexing are still a little bit wrong, but I'm just so annoyed at this problem, honestly. I 0, then you have 2, then you have 1. Okay, yeah, that sounds right. I wonder if this is right, honestly. Because if I is n minus 1, I think this needs to be 2. No. Yeah. I'm honestly, does this work? I don't know. I'm just a little bit lazy and tired right now. Okay. I mean, at least in terms of what I mean is that yeah, I don't know. Like like I'm probably off by one, and I'm just too tired to kind of debug it. But all right, so left and the right. So k is equal to 2. So okay, why is this wrong? What am I looking at? I plus 1k. So for k is equal to 1. Okay. Yeah, whoops. I think off by ones. It still may be wrong though, but honestly, it just doesn't. It's not that interesting. I don't know. I'm rushing the. I'm rushing the off by ones. That's why, honestly, but. 122. What's 122? Well, I mean, I definitely, my answers are really weird. K is equal to 1. Yeah, all these sets should be zeros, I think. Yeah, okay, yeah. That's not an off by 1. I mean, it is an off by 1, but it's also me being dumb. It's here too. I thought I might have needed to write that, but I was lazy. And I was maybe I was wrong that I don't need it. Right now I'm just being tired. I had the solution, right? I just didn't think it would be fast enough. Like what is the running time if this is just equal to, I don't know, what is it? Random dot rand int. Oops. Okay. 400. K is equal to 200, right? Something like this. What's the running time here? Oh, whoops. I don't know. See, like, that's not even that fast, right? So, like, 10 of these things would have been, like, you know, would have been too slow. I don't know. I think this is kind of crap, but it is what it is. It's not even that hard. It's just that it is. Maybe I should have written it. I don't know. I mean, it is just a Leetcode thing, right? Because why did I not do this? Because basically, n is equal to 400, k is equal to 200. Each one of these loops can be 128. Wish, right? So maybe D for domain for 128, right? So that is 400 times 200 times 128. This is 10 million, right? So, like, I don't know, maybe sets are so fast, I don't know. Yeah, because every previous could be 128-ish. I mean, I guess a lot of them are not possible, but all you need is 7 numbers for all 128 to be possible, so I don't know. And then here, this side is going to be n times k, which is slightly slower, but that's still a big number. I think this is a bullcrap problem, because I think if they had just made this like 150, like, it doesn't change the answer, but what is that? 100 times 50, 100 times 50 times 100. But it makes it like you know, I don't know why they did this way to like what are you trying to do here, right? Like this is just I mean, Alex actually said this. Yeah, I mean, I don't know. This is just such a crappy problem as a result. Yeah, I don't know. Anyway, I guess I should have YOLO'd this just to get it AC, but I don't feel that bad about it because I mean I have it on video. You saw that I got it in like, I mean I had this idea almost immediately, and then I had this idea immediately, but then I forgot about the K, and then when I add the K, I did the math and I thought it'd be pretty tight, but this is stupid. Um, it's just mind reading, guessing. I don't know. And the only people who, I mean, I'm sure some people, like the top people, they probably just YOLO a little bit and got it right. But and then you also benefit people who YOLO'd and either cheat or or just really YOLO'd, right? Like they did complexity wrong. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and this explanation, this problem, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.